I'm Bob with Laguna Tools. We have a great video for you today. I call this one Getting Back to the Basics. I wanted to get back to some type of simple CNC router project, and I think we've got one you'll be of interest. And we're also using one of my favorite of the machine configurations, and that's a Smartshop 1. And I like it really well because you can do so much with it, and it's really affordable. It's our lowest price vacuum table machine. The one I'm running is a 4x8, so I can make kitchen cabinets or whatever. And today we're gonna make a whatever. When I saw this photo of this shelf assembly, it really intrigued me because I thought, what a neat, clean design. I thought it was really clever. And then I realized you can really expand this to any size you need, so you could do a whole wall of these. So the challenge was then, okay, we wanna make this, how do we get from this to the CNC? Okay, the first step in this is to try to capture those shapes, and they're kind of unique shapes. So what I did first was I brought it into VCarve Pro as a photo. It's in the background. And then what I really wanted to do is just draw some lines across there and work on it until I got what I thought was the shape that's in the drawing. And here's how you kind of do it. You basically, you click on that tool and you pick a line and you move down and you pick another point on that line and that. When you can zoom in, now you may not hit this perfect the first time, but it's a place to start. You see, as I move along here, it corrects the geometry behind it. Now, I'm not going to digitize this whole thing, but I just wanted to show you the process so when you see what I work on next, you'll understand where that came from. And then you get it close. And then once, if you need to work on that line a little, these are Beziers. So they're handlebar curves. So I can tweak those till I get a pretty good estimation of what that's going to look like. So that's really where you start. And then once, think about it, if you look at this shape, what you really have is you have this shape that just repeats, repeats, repeats. So once I get that figured out, the rest of it's easy. And so this is where I started. So I started with that shape, kind of got an idea of it, and then I had an idea of how big I wanted to make this, and so I scaled it. And then my next step was actually to cut a sample piece or two pieces, fit them together, and make sure they fit. Once I knew my shape was good, then the rest of it would just make it bigger and make more parts. Okay, now here's how the parts lay out, and I kind of showed you where I got those shapes, and there's a little bit of tweaking and a little bit of cutting and seeing if the parts fit before you really make a full-blown project. Now, I've laid this out on a Smartshop 1 that has a 4-foot by 8-foot table. You can do the same thing on an IQ if you want to. Just remember your table size is determining the parts, and my parts are big enough, or my table's big enough to actually put all the parts I need. You don't see them there now, but there's actually going to be the 2 uprights, the shelf brackets, and there'll be some shelves on here too. So this was the first step of getting started. And once I determined, what the spacing was going to be and about how big, that was a great place to start. Okay, now the first process on this is to figure out how I'm going to lay this out on the machine. And once again, I have 4 feet width, so it's okay. So what I decided was, even though my machine has a vacuum table, I am using it, but I'm not really using it for that. What I'm using it for is I'm going to use vacuum to hold a piece of white melamine. And if you watch some of my videos, you know I like double stick tape sometimes, and I like white melamine. So now if you have a machine that doesn't have a vacuum table, you just have to tape it to the table, or use your T-slot fixtures if you need to. But either way, it doesn't really matter. I'm trying to create this surface that I can tape to. Now, to kind of give you an idea of how the parts fall on here, I'm going to turn some more layers on. I'd actually turn the part layers off just to talk about this. So think about what you see on the screen now is where the blanks go, because I've got to know where to put the blanks. These are solid wood blanks. This isn't a sheet of plywood, so I have to know where to put stuff. So that's actually where the locations are. Let's go down here to layers, and there's the shelf supports. And I've actually got there's actually some more geometry here. This is where the parts actually fall into the blanks, and you see there's extra material all around. And then these are the 2 shelves. And the lines you see here are actually what I'm going to use to run a V-bit down there to create that 45-degree angle that I need for that assembly. Okay, now let's talk more specifically about the machining procedures. And I want to really look at this part over here and talk to you a little bit about that. See, for this first end. Okay, I'll turn this off. All right, now this is the finished shape right here that you see. This is the blank. All right, now I'm going to hold, first off, the first thing we're going to do when we get to the machine is we're going to make shallow cuts where the blanks go, and that tells us where to put the pieces of wood. And I already have them pre-cut, so we don't have to worry about that. But now let's think about, how do we machine this? What approach do we want to use? What I found works really well is I want to get rid, first off, I'm taping it down, all right? I want to get rid of the scrap wood, because if I don't, I end up with a bunch of projectiles. The last thing I want is for a bunch of pieces to fly around that got cut free. So sometimes you don't think about that until you cut something and the parts start flying. So I got this idea, well, what if I could first make a pocket that was a little bit larger than the blank, so everything got included, and in that pocket I excluded an island, and the island is the part. So that's the first thing I want to do. Now, by doing that, that gets rid of all the little projectiles or the scrap wood. So that approach is going to do that. Second, what I really want to do is, I'm probably going to do that in 2 passes. I've got enough power here to do all that in 1 pass. You may not. Sometimes if you have a smaller horsepower machine, you may not. So the approach I would use is do it in multiple passes. In our case, I'm going to do that pocket in 2 separate passes. Once again, it's not necessary for power, but if you don't have as powerful machine as I'm using today, you might want to do that. Second, I don't really want to cut all the way through the material. In that pocket, I'm going to leave about 30 thousandths. So think about that as just like an onion skin in cabinet parts. And the other thing I'm going to do in the pocket, I'm actually going to leave about 15 thousandths of material all the way around the finished part. So what that gives me then is it pockets it out, it roughs it out, and that gives me room now to do a final finished pass to produce the best possible edge I can produce on the machine. Hey, while we're talking about this concept of making rough passes and finished passes, let's carry this out a little bit further. In CNC routing, there's some rules. One of the rules is, in wood, the maximum depth of cut is 2 times the tool diameter. So a 1/2 inch tool, I could cut 1 inch deep theoretically. In plastics, the rule is the maximum depth of cut is tool diameter. So if you want to cut a 1/2 inch thick plastic, you got to have a 1/2 inch tool, or you have to do it in steps. In aluminum, the rule of thumb is half the tool diameter is maximum depth of cut. So it's real easy to see when you get into aluminum and you get into plastics, you're going to have a problem. You're going to have to make a cut in multiple depths. And you'll almost always see a little line transition there because the tip of the tool gets hotter than the rest of the tool. So that works out real well. So the idea is just like this. We go ahead and we make a rough cut around the perimeter and whatever multiple steps we need to match the tool requirements. Then we leave an allowance, and then we come back in and we make a final full depth pass, and that produces that perfect edge. So we're doing that in this case in wood. You would also do it in plastic. You would also do it in aluminum. Okay, let me kind of walk through the idea I have on tool pathing this. And I told you earlier that we really want to use a pocket to get rid of all the scraps. So I added some geometry here. So far what we have on the screen is, of course, the actual shape of the part. And then we have what the blank size is, all right? I added another piece of geometry on a layer called pocket. And all it is just offsetting the blank to give me a boundary. Now, what I'm gonna do is I'm gonna make a pocket. So I'm gonna open this up, and I've selected the geometry already for this operation. So this is selected as well as the inside one. So you have a boundary and you have what's gonna be excluded in the middle, or what you would call an island. Okay, I'm cutting through 0.72. The material is 0.75. So it's not going to cut all the way through. This is going to still all be connected. And I'm doing that partly to make sure these small narrow parts don't move. All right, now what controls depth of cut in VCarve Pro is this. I'm saying the depth per pass 0.4. I'm forcing it to do that in 2 passes. And this allowance, remember I told you earlier that we wanted, when we do a rough cut finish pass concept, we want to leave an allowance, and that's in VCarve Pro, that's where that's at. That's where the 15 thousandths came from. I hit calculate, and let's see what happens. Let's come back over here and let's turn this off a minute. Okay, you see our geometry. I turn this on, and first let's look at, there's where the tool paths go. If I click solid, that gives you a little bit better idea of what's happening. And here's the 15 thousandths clearance. So that's the strategy we're using to get rid of all the scrap material, but leave a little bit so that we can produce a perfect finished edge on the final product. Okay, now that we've got the scrap really pocketed out, we've left our part a little bit oversized. Now we're going to come back with a finish pass, and let's open that up and I'll show you how we're going to do that. Same tool, this time I'm cutting through the material 10 thousandths. Remember the material's 0.75, my cut depth is 0.76. When you do a profile tool path, passes are kind of set a different way, or you can set it. In this particular case, I'm doing it in 1 pass because remember I want one beautiful edge there, and I'm going around the outside. And on this one, I'm actually going to climb cut because sometimes you get a little bit smoother edge. This wood's a little bit softer, so that should produce it when you see the tool path. That's what it's going to look like, or if we showed it as a solid, and now you see that it goes down to the line. If we actually highlighted that one, this is what's going to happen. Okay, now I applied the same ideas on these. These are brackets, and you can see here's a blank. I took space 4 of them because I need 4. I have 2 shelves. And if you look at the profile, here's what the pocketing looks like. Here's the finished pass. So it's the same idea, rough pass and a finished pass to really make it nice. And then the other 2 parts are shelves, and I basically, once again, went around those profiles, went around those, and then I came back and did the finish pass. So I applied the same strategy on the outside of all the parts. What I wanted to do to create this bevel on the edge of the panels was to just take a V-bit. So I took a 90-degree V-bit, that gives me the 45. I went ahead and created a longer line so that it starts before I get to the material and leaves after. And that's what you see right here. When I click this, you'll see that. And now you see there's where the tools go. So after the shape's cut out, then this is going to come and put that nice 45-degree angle on there, and that fits in. And that's all the machining that's going to be required here. Okay, on VCarve Pro, there's really 3 steps. The first step is creating the drawing, which we did, all right? The second is applying the tool paths to the drawing, which we did. And the final step is to output code for the machine. So that's what we're going to do now. Now, I could create one big program that uses the 3/8 tool all the way through. What I think I'll do is I'll work on sections at a time. So I think what we'll do is we'll cut the uprights, then we'll cut the brackets, then we'll cut the shelves. So we're going to break that up a little bit to make it a little easier. I'd like to be able to do one of those steps and stop and explain a little bit about it. But what I did first was I created a program called Setup. All right, so if I click that, you'll see. So what it's going to do is it's going to go around, it's going to cut about 20, 30 thousandths into the millimeter. That shows me where to take the parts down. So I need that, I call that Setup. I made all this part of the same drawing. Okay, then the second program I output does those. So it does the rough pass, finish pass on the upright parts. Okay, then the next program did the same thing on the brackets. And the final program actually does the shelf profiles with the finish. And then I'll come back and I'll do a program that just does the V-bits, because once again, that's a different tool. Okay, now we're ready to transfer the programs to the machine control. On the handheld control, there's actually 2 ways to do this. I'm going to copy these to a USB key and put them in a control. I could also, from there, copy it into the control internal memory. Those have about a half a gig of space. Or I could actually bring the controller over here, plug it in, and it shows up like a USB drive. So there's a couple ways to do that. We're going to do it the simple way today. If I were going to schedule a day's production, I probably would just bring the control over here and dump it all on at one time. But we're going to the simple route today because this is getting back to the basics. So I'll just right-click this, say Send to, and there they are. Okay, we're in the studio at the main Laguna Tools building. I always like to be in here because it's like a shop at home when you close the doors. The floor space is about equivalent to a 3-car garage, so it's about the size of a lot of shops. The machine we're using today is one of my absolute favorites at Laguna CNC. That's a Smartshop 1. And the reason I like it so much is I can make almost anything with it. It's a 4x8 machine. It has a vacuum table so I can do panel processing. Has a 4 horsepower liquid cool spindle. Liquid cool means I can run it a long time before it gets hot. We made this with very, very good components. This is a member of the Smartshop family at Laguna CNC. So that means the base frame is all welded structural steel, one piece. We have the same gantry designs all the Smartshops have. Contoured guide rails, precision rack and pinions. Okay, now the spindle is actually housed in this dust collector shroud. So if I open the door and move the door back, you can see it. There's the actual cutter in the spindle. Now this entire spindle assembly then moves up and down on a precision ground ball screw. And that's where we get the accuracy in Z. Okay, before we get ready to cut, let me talk about one more thing, and that's how we actually have this fixture. Now, this machine has a vacuum table. It's a 4x8 vacuum table. It has our universal vacuum system that we put on all the Smartshops. All right, this one has a 10-horse vacuum pump, and we have 6 independent vacuum zones, so you can use those for special setups if you need. Now, what I'm actually doing with it is I'm using an MDF board that's been fly cut, and I've got this melamine panel that I really like because double stick tape sticks so well to it. So I'm actually going to hold it in place with vacuum, but we're actually going to do all our setups on this material. This is what we call the Laguna HHC. That stands for handheld control. And I really, really like it. It's so simple to use. We tried to create something that almost anybody could figure out how to use. Now, I've already copied the programs from my USB key in here, so they're already in here. I'm basically ready to start our process. Let me load a program. The first thing we're going to run is the one I call setup. And remember, that shows us where to put the blanks. Select that. Now, when we turn this on, it's going to get noisier. Okay, this is our setup, and now this shows me where to put the blanks, and this is what makes the connection between VCarve Pro and the machine, this file right here. Now what I'm doing is applying double stick tape. It sticks really well to this white melamine, that's why I like melamine for this. Okay, let's see if I can get this lined up. That looks pretty good. We've got a little extra space there. All right, let's get started. Okay, this came out really nice. I want to point some things out to you. We pocketed it out. We did it in 2 passes, and you should have been able to see those steps. And if you notice, I left about 20 or 30 thousandths of material here. Then when I came back in and did my finished pass, that cut on through. So it just left a magnificent edge there. Now let's cut the shelf brackets. Oh wow, these came out nice too. You can see where we made the rough pass, pocketed the scrap out, left an onion skin, did the finished pass. Those really came out nice. Okay, now our next step is to cut the shelves out. We're going to do that in 2 operations. One is we're going to cut the perimeter just like we did before. 2 rough passes, a finished pass. Then I'm going to change tools and I'm going to cut that V edge or the bevel edge with a V bit. You know, before I take the rest of these parts off, let's talk a little bit about using double stick tape and when that's appropriate and when it's not. The rule I have is classification I call prototyping. And for prototyping, that means I'm making 10 or less in quantity. If that's the case, then I use double stick tape because it's so easy. Now, if you came back and you said, hey, we've got to make a production run of these, it's a different animal. Then we start using special fixturing and vacuum. But just think about it. If it's 10 or less, tape it. If it's more, then you put a little more time into it. All right. Wow, look at that. There's the test right there. Look at that fit. That's as good as it gets. Center that, and then we'll take this one. Wow, it fits so it's you know, we hit it dead on. There's where our bevel fits. And we'll get that centered, and that's our shelf rack system. Let me move these down to the next level. Okay, now see, I can actually, if I want to space my shelves differently, these just drop into different areas. And you can tell how the bevel on the front fits into here, and it locks it all together. So it's really clever. And you know, you could have a whole wall of this. Your shelves can be any length you want. You can have these supports any length you want, so it gives you a tremendous amount of flexibility. It's just, when you look up close, it's amazing. It just fits perfect. Well, why does it fit perfect? Because we're cutting the same line. We're cutting one piece on one side of the line and the other piece on the other side, so they basically have to line up. Think about where this came from, that we started with a photograph of a product like this. Now, keep in mind also that you can make this as thick as you want, and you can make your shelves as thick. It actually, technically, you could scale this. As long as you keep the proportion, it's going to work at any size. I hope you enjoyed the video. The intent was to try to get back to the basics and make some parts that are hard to make by hand. And that's why we selected parts that had radiuses. And at the same time, we selected a product that has lots of different applications. I hope you enjoyed the video. If you have any questions, call Laguna Tools at 1-800-234-1976, or you can find us on the internet at lagunatools.com. Thank you for watching.